Okay, so the aim of this current project is to port this desktop game to the web. There's a couple of different components, a shader for the background, a shader for these textures. Clearly input is being read with keyboard presses, stuff is being rendered. Yesterday, after banging our head against a wall for a long time, we got both of these shaders rendering. In particular, we can kind of see that there's the earth in the background here, but also now a blue rectangle, because I figured something out. So I was a bit annoyed yesterday with regards to the all of like the memory issues that we were running into, and so I changed. I looked into a couple of things, looked things up, and figured something out. So it turns out that in the build file, you can actually specify what you want the stack size to be for a WASM. And so previously this didn't exist. So if I comment this line out, for example, and then try and compile the project again. See, I built it here. I don't know why like the entire build script has to generate again when I just comment that line, but it's Z13. Things are a bit faster in Z14. If I relaunch the HTTP server and run it again, I'm gonna have to clear the cache. Nothing's rendering. We get an index out of bounds because the initial stack size for the WASM, apparently many places on the internet said it was 1 megabyte. I couldn't actually find in the source code where it was specified to be 1 megabyte, but it seems to kind of match the things. And so simply by saying increase the size from 1 megabyte to the page size times 1,000, and I think the page size is about 64 kilobytes. So we're giving it like 64 megs of RAM, which is decent. It's enough. Then yeah, when it's run again, then it actually works. It's failing now. Once you run it again, ta-da, it's working. So in particular, this means that all of the adjustments we had to make yesterday, such as using the 420 version of the image, we can go back to like the original full size. Okay, so blue marble. Yeah, so I think yesterday when we tried having the blue marble, the 408 version, and the quote, things failed. But now with the increased stack size, it will work. What this also means is that there's no longer any issue about actually just like assigning some of these values like truly as stack values within functions and then kind of forgetting them instead of putting them in a global section. And so I think the first thing I wanted to do today is just use the new stack size to clean some stuff up. In particular, another thing we need to clean up is the compiling the shaders. When we were just getting stuff working yesterday, in order to stop like the headaches, we just like duplicated all of the code that compiled the background shader to the kind of the Pluto shader. It will be good to just contain this within a single function. I realized how to do this yesterday evening, and then we'll have to start playing around with the background buffer. But yeah, first things first. And so in the current way that the QI file is unloading, we have these blue marble pixels and blue marble bytes that we're just using as like temporary space. So we can actually get rid of these ones, or rather move them into the decompress parts. So save that to 1, save this to 2. And then in the part of the code where we do save these, we can instead just insert them here. So yeah, assign this temporary but large stack space. It's only like a couple of megabytes each, but even so, to have those there, decompress them into those things. Once they're decompressed, we then copy them out into the actual bytes. Okay, nice. I think I can get rid of this one. Build that again. Let's just check this is working. Great. Okay, so that's like one issue that has been just completely solved, and actually we should like just check things are fine. Yeah. And then yeah, now it's time to like clean up this like compile background shader and to combine both of these into one. So we can have a new function called compile shaders. And how do we want to do this? Compile shaders. So I think here is where we want to we'll create like a single function that compiles just one shader, and we'll need to think about a bit about how we want to do this. So for our current shaders, we've got our background shader program, and we want this to be compile shader something in here. And then we also want to say like the color, what even is it called? The color texture shader, color texture shader program. And then we'll have something in there. So in terms of what we need, let's see. We're going to have to pass in the source. Of both the vertex shader and the fragment shader. So you can say vertex shader, the vertex shader is going to be not just like a string, but a null terminated string. Then we also have our fragment shader, which likewise is a, why can't I press 0? A null terminated string, and then here's like the hard part. So this is where we need to all of these should be like source. Yeah. we need to pass in an argument to handle how the linking is going to happen. So currently in the background shader, we pass in the a pos at before stuff is linked. And so I think here we want to pass in a slice of strings, and each string we're just going to look up where it is, bind it, and then link it, and we'll do that repeatedly. So here we want to have a attribute list. So this is a slice of strings. Here we'll have to specify them. So actually, before we do the color texture shader, we'll just do one to start with. So we can say background shader attributes, and so this is going to be some unknown. Well, we know exactly what it is. It's a list of one string, and this is just going to be a pos. You can even put that in one line. Okay, so then here, when we're compiling the shader, what do we call these things the vertex background source and the fragment background source. Fragment background source, then our background. Okay, let's just put these on separate lines. Background shader attributes. Okay, and then for the time being, we'll leave it like this, and now we want to copy everything here into the compile shader function. Let's comment that out. Okay, and now I need to deal with this. So vertex background source handle, you can just say vertex source handle and fragment source handle. These are just going to be the arguments that we are passing in. So this is the vertex shader source, fragment shader source. Those are the same, or rather vertex. We do want to call this the vertex shader and the fragment shader. And then we're calling shader source on I think we can just replace background with shader everywhere. Background shader, vertex shader, like that. Then we're compiling them here. Check to see that the vertex and fragment shader is compiled. Play stuff again. Here we want to improve the error messages. Is this the 5th time we're adding in a debug message if it worked? I have no idea where they disappear. A debug, vertex shader, compile. fragment shader. Okay, all of that, and then here's the part where we need to use the other argument. So let's see. Like I'm so used to like splitting the screen one way. It's taking me a while to do it the other. So this is where we want to use the attribute list. So now we want to say for attribute, well, in the attribute attribute list, we want to say we're calling this background shader program. I think we just want to call this shader program. Attach vertex to the shader program, to the more backgrounds to change. Attach both the shaders. Okay. And then, yeah, bind to the shader program. Instead of a pause, we want to bind the attribute. So constant string is expecting something that is comp time. And like technically this stuff is. So we might just change it with string then. But since we're like going through it in an array, we'll just do this. So yeah, get that, and then do we need to call it? Yeah, we're getting the location of it, and then we're saying assign this location, this to location blah. Okay, so what are the zeros here doing? Wait, something's wrong. Or maybe that's just it. We simply just leave over each of those. Yeah, I think that's it. Okay. Let me link the program. Check that it was okay. And then if it succeeded, we then want to pass this back. So we want to pass back a zjb.handle, and in particular, we're passing back the program. So we have here shader program. I guess we want this to be a const. And then we're returning shader program. Return the handle. Okay. So yeah, let's try and compile this. We'll also want to draw it too. So we can see the area down below where we use it. So I guess we drew it in this part when we were rendering the background color. And yeah, there's no reason why we shouldn't just be able to call this and draw it immediately. So yeah. Lots of errors. 273. Expected expression found const. Array literal requires address of operator to call a slice. Wait, that's right. So yeah, here we want to just like pass it as a slice. I didn't say launch Emacs. Unless we can actually just define this as a slice in here. Does not support array initialization syntax. Okay, so yeah, define it like this, and then yeah, I'm really surprised that we can't just convert it to a slice this way. Oh, maybe it's the type. So when it says it's discasting the const qualifier, I think we can define it like this instead. Yeah. Okay, and now we end up with runtime known argument faster comp time parameter. We do want this stuff. We certainly want this stuff to be comp time though. So comp time argument there. Comp time argument for the pricing shaders. Okay, that's compiled. And will it run? Let's see. Okay. Looks like it did, but we're not seeing anything show in the background. Why? Yeah, we're getting both linked. Yeah, I could have sworn from when we used this below. It's getting drawn. I wonder if we instead disappear these other values. Okay, it is being shown. We were just overriding it for some reason. Okay, maybe we should just start to fix this then. But before we do that, we'll save what we've done. So we did change a lot. So yeah, so given that background shader here is being displayed, we can delete the previous huge thing that we commented out. Okay. Yeah. So get def. What did we change? Begun to factor shader compilation, increase stack assigned wasm stack space, or increased stack space stack memory assigned to wasm. Okay. So yeah, let's make that full screen instead of just half the screen. Why is this happening? Where are the drawing commands? So I can see it's we're either passing it in the background buffer vertices that are incorrect, but those look fine to me, or we're in the shader, we're like positioning them in some weird place. This may actually be an issue with the shader. In the vertex background, what are we doing? No, we're just saying read this stuff in. Okay. Well, maybe we are actually drawing it correctly, and something else is drawing this box at the top. Where are the draw triangles commands? But this is the only one activated. Okay, it is something wrong with this. Something wrong in here. Maybe it's in the fragment shader instead. I'll make this full screen. I think it's this line here. A unit coord and normalized coords. So let's see, here we so I guess we're dividing it by 1,000 here, but the canvas itself is 500, is it not? Maybe we need to adjust this to canvas. Yeah, it's 500 here, but change it to 1,000. So we want to adjust it back to 500. This moves it between -1 and 1. And then that should be as usual. Oh, okay, now it's just not rendering at all. Oh, link program must have a compiled fragment shader attached. Oh, I think it should be 500.0 instead. Okay. All right. Okay. So that's the distribution looks better now, but yeah, we're still not rendering it above. Why? So if we go to the main function where and then we jump to the setup, the array. Oh, maybe since we've left the setup background array buffer commented out. So maybe we weren't actually passing any values in, and it's somehow rendering this with like 0 values. That's a bit embarrassing. Okay. And surprising that it still renders. No, okay, that's apparently not the issue. Really? Really? Okay. Yeah, I'm so confused. I could have sworn yesterday we had this like on the entire screen, and now it's just like this. Okay, so say I change these ones to like zeros, or maybe even negative 0.5. What does this then look like? Why does this look the same? What is happening? Really? Okay, let's do something that should be kind of clearly incorrect. I wonder if this is like to do with the order with which we're assigning stuff. Okay, maybe we've pushed the data. Are we somehow like assigning this to it? we're saying clear the color, and then just, yeah, use the background shader program. Is this where we need to say, like, activate the VBO? I feel like we do, like in the sliding puzzle, when we actually rendered that, what did we do? So after we cleared the background, we then said, yeah, we then said find the specific vertex array, and then bind the buffer here. So I think we're gonna have to do something similar here since we're now using multiple shaders. Let's just save this. Okay. So in the WebGL examples, say in the rainbow triangle one, did we even do this? In the animation frame, no, we simply said use the program. Okay, that explains perhaps where the arrow is coming from. So, yeah, so in the animation frame, once we've set this stuff up, we want to like translate these. So the use program call, we're already doing that. But we need to basically bind the background VAO and then VBO as well. So what are the steps for this? What's the equivalent thing? Well, when do we use bind buffer? Oh, so here we're making it and then it's disappearing. We need to be saving this. Or are we overriding it? Yeah, I think we're overriding it. Okay, that explains what's happening. So we should have like a background VBO and then some other one. Okay, so we can call this background VBO. The other one will change. And then when we're doing the background, yeah, let's just replace triangle VBO with background VBO. This one, no, since this one's more complicated. We're gonna have to copy or take this bind buffer. Cool. So now in the animation frame, now in the animation frame, the first buffer we bind is going to be the background video, and I'm kind of concerned there's this other like bind vertex array. I'm wondering if we have to like create our own version of this. Hopefully not. That would be super painful to debug. Okay, let's just test this out. Compile, run it. No, okay. Damn it. Maybe we will have to do this. Bind vertex array thing. Okay, so a theory that like we're defining some other VBO thing that's like stuffing it up. I think we could, um, if we don't let the Pluto array buffer get called, then this would be one way of making sure that doesn't happen. So compile Pluto shader. Yeah, get rid of that for the moment. Okay. Yeah, so it really is something happening with the other array buffer. All right. Get rid of the rainbow triangle example. So in the desktop version, we say bind vertex array to the background VAO, and then we're binding the color texture VAO. Okay, so I think we may need to assign the different shaders to and all of the attributes to just these different VAOs. Okay, so then what's the analogous thing in our program of the of this thing? That's like one. That's something we need to consider. I think I remember in the documentation, one of these was like the equivalent of like bind. Something. Is this like, was the create buffer like generalizing this? GL create buffer. Okay, yeah. So this is what I remembered. It's like it's basically the GL version of GL gen buffers. Okay. So then in the main, when we look up gl.gen buffers, okay. Oh, so this was the thing that was doing the VBO, not the VAO. Is there like gen vertex array? Oh, okay. No, I'm like cycling through everything. Everything except port. Okay, so then what do we do? Okay, how do we, maybe looking how we set these things up could help. Yeah, it's like the first thing, It doesn't look like you can go higher. Like, I'm wondering if, like, switching the buffers makes them like forgotten in some way. Like, I'm wondering if after it's switched, you have to call all of this stuff again. More spam. Stream isn't complete without it. Yeah, maybe this is like maybe some other people have ran into this issue on the internet and we can look it up. So we have bind buffer here. Here in the thing we've now disabled it. Here we're calling it again. GL bind buffer forgets attributes. Okay. How to restore an attribute binding after program is unbound and rebound. Okay. Okay, yeah. So in normal GL, the VO is to save you having to do that. Maybe we just have to do it multiple times in WebGL. I would be really pissed off if that was the case. WebGL, but it wouldn't surprise me if this is the case. What is the logic of binding buffers in WebGL? So it has a bunch of internal state, as we know. Apparently, what? Like, I don't believe that these are like super global state. Oh, the attributes are global state. Are you joking? Oh, this sucks. This is ridiculous. we have to rebind all the that sucks. Okay. That would explain this stuff. Okay. Before going down that route, since that's another entire thing, let's continue factoring the compile, the shader compile function. So yeah, we're doing compile shaders, and we want to replace make this full screen. We now want to do the color texture shader program. Shader program. So currently it's called Pluto shader program. We should change this. Pluto shader program with color texture shader program. Okay. Color texture shader program is equal to compile shader things. We need to define this. So now we have color texture shader attributes. So this is now, we might as well just define it as like unknown maybe it's better like constituate. Here we have quite a few. So what do we have? So we've got a pos, a color, a tech coord, and a lambda. A pos, a color, a tech coord, a lambda. So now when we compile this, we want to pass in the vertex color color texture shader, which is the source. Vertex color texture fragment color texture source. Then these attributes color. Again, we should put these in separate lines. Color texture shader attributes 0 this dot dot okay. Alright, and now let's try compiling this. Unable to infer array size. Okay. I'm really surprised that that's an error. Okay, compiled. Let's see if it runs. Also has this finished uploading. It has. Get rid of this. Oh, okay, we need some of those. Oh no, we got a link fail. Yeah, we got a link fail. alias attributes at location 0. Oh, I think, well, we ran into this problem last time, so we know exactly what it is. We're assigning everything to position 0. Oh, here we're going to have to convert it from an I size to an I32. Int cast I. Okay. But otherwise, it is both linked. Great. So now we can, we should be able to clean this up. I feel like just to check that it truly is working, we should see some textures on the screen. So let's activate the setup Pluto array buffer, and in the animation frame we are we should like turn this on again. So if we do the another bind buffer call, but here we're using, I think it was like the triangle VBO. Yeah, the shader is clearly compiled and working. Okay, git add, git status, commit, finished factoring shader compilation. Yeah. Okay, that's working away, so we can continue to clean up a lot of stuff. So now that compile shaders is working both of them, we can eliminate this compile Pluto shader line, and therefore all of this code. We can also rename this like decompress Pluto to like decompress images. Okay, and now, yeah, now for this fun of like the background array buffer stuff. So since these attributes apparently are global, it means that we need to call them each time that we issue a draw call. It's just ridiculous, but I guess the way it is. It's so dumb. There's lots of words I know in my head, I think, what I want to try. So instead of setup, let's rename some of these. So maybe this can be setup background. Setup background attributes, or rather, like we are pushing data though, that's the thing. I wonder if it's truly just this stuff that we can, if it's truly this stuff that needs to be adjusted each time, or if it's just the entire thing. Maybe I should just read some of these words and find out. Yeah, every time you call draw limits to draw arrays, however, you have the attributes set up, is how they'll be used. Yeah, every time you redraw something different, you rebind all the attributes needed to draw that. Okay. So maybe we just change setup to like set. Set background array attributes. Like, it still feels weird that, I guess I'm just used to the VA, like the pure OpenGL way. Yeah, setup background. We'll just call it setup background VBO. Okay, it kind of will be an issue if we're creating this a bajillion times. Maybe it's better to just can we just create a single one then? Okay, let's, I feel like I should just save stuff before we do anything. We did, right? We haven't changed much, yeah. So now I'm wondering if we can honestly just create a single buffer and then we just, we just like call it differently. We just say, we just say like we bind this data, these attributes, draw stuff, and then we just bind it with different data and then draw stuff and just move on. This was weird to do, but I guess we can try. Okay, so copy that. And where, I guess when we set up the OpenGL context, we can do this. Fn main. This keyboard is driving me nuts. Okay, init WebGL context. So, so I think here is where we can try create a web buffer, but then note since there is no VAO in like WebGL, basically like state is not saved. So just make one buffer to get reused everywhere. Possibly. So now let's call this a global VBO. And then might delete like okay. So in this setup background VBO, we just want to use the global everywhere. So bind the global VAO, and then yeah, use all of this data. That's all fine. And so we want to call this in like animation frame. So here's where we say bind vertex global VAO. And like, it's happening all the time, so I don't think we even need to ever call this actually. Except maybe we call this once. Global VBO. Where after we define it, we set it. And then we just, that's it. We don't touch it again. The very first time is this buffer data. So render the background, set up background VBO. Then not using that anymore. Then use the background shader program. I feel like this should be part of the VBO. Should this stuff be, should we call use program before or after we set up the attributes? Probably doesn't matter. I kind of want the use program to be somewhere different. Like, just to make it super clear that it's happening. So you render the background, set up the VBO, do that. Then it's on with the stuff. Then we draw it, and then the next part is where we want to set up the other textures. And so now we want to say we want to we don't even need this in main anymore, apparently. So now we want to replace set up color vertex buffer or color vertex VBO. And then, yeah, all of that stuff. Let's create buffer. Apparently we don't need it. Don't need to bind it. We should just check out what this like WebGL buffer data does. Do we have the specification? Okay, and then yeah, then we set all of these attributes. Then we do like the texture twice. Maybe this itself can be factored in some way, but we're not touching it for the moment. And then we should use like the core the use program. Yeah, so now we want to say set up color vertex VBO. Use the program and then draw the stuff. Okay. Z13 build sliding puzzle. Okay, that did compile. Aha, great. Okay, apparently all of these abstractions that could, at least in OpenGL, are used for like save the state, so you don't need to set it a bajillion times every render frame. You just don't mean anything. You're pointless abstractions in WebGL, and you just set everything every time. So, okay, that's kind of great actually. It's background is rendering, textures are rendering. So, maybe we should just save this and then clean it up a bit more. Yeah. What have we changed? Quite a bit. Got both shaders drawing. Okay. So yeah, so we're really close to adding in like the game logic and getting stuff working. I wonder if I'll leave that here. is no, seemingly, no way to save state, attribute state, everything seems to be global, so you just make one V to get used everywhere. Okay, so now that there's this global VAO, we can just get rid of, we can delete this stuff. We want those ones, just like we want our textures. Okay. Node for above. So yeah, we can clean up this like defined background VBO, I think. And we're not binding the background triangle GPU data. Background triangle GPU data. Okay, so this stuff, the color vertex VBO, we're now going to have to change if we want to port over the rest of the sliding puzzle code nicely. So we hard coded this, but we actually want this to be dynamic. So, okay, so how are we going to port this stuff? I kind of want to like factor this stuff out, maybe. Oh no, we can't just create a texture each time. No, that's going to completely blow the whatever stack we have. Oops. Yeah, I mean this needs to be factored out. why don't we just create something called make textures, or like, yeah, just create textures. No, it was really good. I read through this. Kind of scary. I could have missed that. Okay, so let's do, after we compile the shaders, we'll do create bind textures, or rather just create textures, right? Well, we are kind of binding them. Yeah, create bind textures. Oh, I must charge my iPad. Battery is low. Okay. So yeah, let's bind these. That will also help just to factor out this code. So we're going to compile shaders. Create bind textures. Okay, and then here, yeah, all of this stuff. Yeah, create a texture, bind it. Set this stuff. Yeah, do that. Create the texture, set options, do that, alright. And then that means that in the color vertex VBO, yeah, why are we setting up like the textures in the VBO? We can just factor all of that out. Let's try building this again. Build fail. 636. Background triangle GPU data. Is this going to do anything with the memory? No, it should just be it's just like casting it basically. Should be fine. Okay, no, that did work. Okay. So now what? Let's delete this. Maybe we should put this in here. Okay. factored out texture generation. We should set this up. Now this is like render the tiles. What are we even using this lambda for? Is there even a lambda uniform in this? I didn't think there was. Can we just get rid of this? So within shaders and the fragment, yeah, there's no lambda uniform. Kind of weird that isn't giving us an error. So I think we can just comment out all of that. This active texture, I think this should happen earlier in the setup texture thing, create blind textures. Undeclared identifier time something seconds. Okay. That's fine. Okay, let's just say save everything again. It wasn't like that significantly. More cleanup. Okay, so I think now we're truly in a position to start to add in like the previous the logic. So So we're going to have to replace this temporary data with stuff that we generate. We're going to have to do like a buffer sub data command. How are we going to go around this? Okay, so in the, this is like the older one. This is the original. So like yesterday, when we courageously tried to do everything at once, we like copied the stuff in, everything failed, and then we deleted it. We wiped it. So now we want to copy in this like color texture vertex, which really is just like a vector of 8 floats, of 8 F32s. There may actually be some CPUs that do vector operations on this. Certainly if it was just for, most CPUs do that. But 8, less certain. So I think yesterday we wanted to port over this, like the vertex buffer index, and kind of get a structure going so that we can, when we draw, we can just say like draw something, push all the data to some large buffer, and then at the very end draw everything in the buffer. So to do that, yeah, like the background pattern, rendering the background pattern basically trivial. Okay, it's actually more like this. But we've clearly got that part working and that part ported. The stuff that is not ported is the rest. So here we're saying switch to the color texture VAO, which we can't do in WebGL, sadly. I can see this. I can actually see it as like a philosophical point. Like, why keep track of this VO and VBO when you can just like generate it each time? Like, why not? Like, it's not that hard, I guess, to generate each time, even if that is a lot more GL cores, which can add up over time. Okay, and then we're, interesting, we're actually like setting the texture here. Did we do that in, I guess we must have done that in the other one. Someone is messaging me. But yeah, here's like the part that we need to port. Being able to call buffer sub data, and everything that entails. So now that we've increased the stack, we can very easily create like a buffer data that's this large and everything else above. So I think we can now copy in the geometry, color texture vertex, this vertex buffer, this rectangle, and this stuff. But we're now going to have to create a separate function to convert everything in the color texture buffer to a U8 before we before you render it. We're gonna also need to copy in the, keep this over here, copy in the thing that draws to this. What draws to the vertex buffer? Here. This was our draw color texture thing. Figure out and store the GPU data that would draw a rectangle. Yeah. Oh, okay, we're gonna have to copy in vec4s and stuff if we don't have these already. Yeah. Let's see if we can just, we're not even calling anything, but if this would just compile. Okay, it did. Presumably we haven't blown up the stack, but let's just check it. I'm still skeptical. Okay, haven't blown up the stack yet. Like we did assign it to be something big, so should be okay. All right, but now the more tough thing. So let's see if we can render the quote like we did here. So we're gonna have to like compute tiles. So render the background say pattern. And then we'll have like a to-do here, to-do render the tiles. For the time being, let's we'll comment all of this out. And instead we want to replace this with what we're doing in the desktop version. So in the desktop version, when we draw the quote, we do the following. Okay, so we say, we reset the vertex buffer, make the quote texture active. This we need to change. Bind texture, we want to just replace it with this line. Bind texture with the quote texture. Then the game window has dimensions 500 by 500 in the web version, which inform these values below. So now let's draw the quote at like I guess 275. And what, like maybe 400. Fine. And then yeah, make like a rectangle. where is quote width calculated from? Oh, that's, it's actually just from the texture. And then this stuff is putting stuff on the vertex buffer, and then here's the hard draw call we need to change. We'll also need to change how we set up the buffer so that this happens as well. So let's replace the draw arrays first. So yeah, GL triangle 0, the 6 here is now replaced with this int cast. See, cast that, yeah. Cint, let's just be super clear what that even is, I32. Okay, and now I have to replace the buffer sub data call. So now we can do GL context call. Surely this exists in the specification. Buffer sub data, yeah. And what? How does it work? Buffer. Target offset source data. Oh, it's like one of the arguments is being removed. Really? Yeah. What was it in OpenGL? OpenGL book. Why are we looking at this? We could just look up the specification online. GL buffer sub data. So yeah, what argument is being removed? So it looks like the offset disappeared. So here we have, yeah, oh no, target offset data. Here it's target offset. Oh, the size is gone. Why? Okay, I guess the draw call, well, no, I don't, I'm really confused. How is it meant to know how, yeah, how is it meant to know how much to copy? Kind of concerned this is in WebGL 2 instead of WebGL 1. Okay, It exists in GL1 too. Okay, so how is this doing it? So yeah, we have to call. Okay, I guess this does dropping. It still feels so weird to like just drop this. Okay, I guess maybe because of the way like the JavaScript's doing it, since you're passing in the data object, that itself probably contains the length anyway. Okay, I guess that works. I mean, of course, the smart way would be just to pass the slice that contains the only things you actually need, which is the length and the pointer. But hey, if every programming language is like that, maybe we wouldn't even need Zig. But alas. Okay. Okay, so it's just the target offset and the data. Target offset data. Wait, it doesn't return anything, right? No. Okay. So the target is another GL array buffer, presumably. Yeah. Then the offset, which is just 0, 0, and then the data, and then so yeah. So now we skip the length, and now we need to have a like object instead. So we also need to convert the. We should have a separate function. Convert the buffer data into a U8. So this U8 we might be able to do, instead of having to write like another conversion function, we could probably just modify the thing after main we already have to do that. Like this is like each of these things is a vertex, and each of these vertices is actually it's fine. It won't take that long to write into a U8. So here we want to say maybe we should create a separate function for this. Oh no, we have lots of stack space as well. Okay, so we can say vertex buffer U8 is equal to oh, it's not even a U8 though. Oh no, we're passing. Oh, this thing, since we're not doing the texture, we don't have to pass the U8 thing. We can just do like the data view as usual. Okay. So we want to make this equal to like we know the size of all of these anyway, but so we can just make it like 400. This is absurd. 4,000 floats. If this exceeds the stack space, who cares? We'll just increase it. If like bloody Google is like, yeah, we should make like the WASM memory like 4 gigabytes, then who cares if the stack memory is like 50 megabytes. Okay, so we'll just make this equal undefined, and then we want to say, but we should that's fine. Well, it's probably better to write this as, make it clear it's coming from somewhere. And we can say for 0 going up to the vertex buffer index, and this is representing just the number of vertices, yeah. We want to say vertex buffer f32 8 times I plus 0 is equal to vertex buffer I dot the element. So we have this packed struct. Let's call it texture vertex. Yeah. So the first one is x. Let's copy pasta. Then we're assigning it y. Then the red. Then the green. Then the blue. The tx. The ty. The l. I'm just slightly worried with just like the colors might be weird, so while we're doing the quote texture for now, we'll replace the quote QI with like the blue, just so we see something obvious. But we'll update that. And it should be 1, 2, 3, 4, 5, 6, 7. Okay, and then we want to say we have to like turn this into a the object ZGB, like search object const GPU, or like quote GPU, like quote GPU data object is equal to ZJB dot this is, we need to do data view, right? Yeah. Data view. It's a slice, but a very specific slice. In this case, it's the vertex buffer f32 from 0 up to 8 times the vertex buffer index. And then we want to pass that in here, quote GPU data object. Okay. There may be some like weird things with like the sizes going on, but especially like I think when we like normalize data. Okay, let's just think about this ahead of time. So, okay, we're passing in these tech coordinates, and we shouldn't have adjusted them at all. No, we're just calmly just adding them in. So I guess here I think we do want to start adjusting them now. We might just divide them by 500 for now. And then unit square post. Okay. Oh, so much is going on. Oh, we really need to like reset the vertex buffer index. Oh, we are doing that. Okay. I think this is it. Oh no, we have to set up the buffer to be dynamic, I guess. When we call this. Yeah, so all of this stuff is now redundant. And instead, we want to have buffer data. We could even just use this one. So here we've said buffer data. Oh, and so here's like another an overloaded version of the function. So gl.buffer data WebGL. But I think this is actually we could use this version. So saying array buffer, the size, weirdly it's saying static draw even though we're like pushing it dynamically. Weird. These overloaded functions accept like the same number of arguments with different types. Oh my goodness. Oh my goodness. Look at how what. Nicki Minaj, we need some more songs. We need some more songs. Buffer data. This is taking way more than 3 arguments. Okay, I guess we're just able to, yeah, call it in like the standard, in the WebGL way, and even though it's like not defined here, it still works. Interesting. Or maybe it's just the Mozilla the Mozilla specification. Buffer data. Oh no, we just are we really just passing this the wrong number of arguments and it's still rendering? Yeah, I think it is. Oops. Okay, so here, this is wild. So beforehand we've been passing it, yeah, array buffer, that, and then static draw, and then apparently this stuff we can forget about. Okay. I did not expect that to be different. So then, when we're setting it up here, we're now saying make it dynamic draw, and we want to put a size in here. So beforehand, if we had the 4,000 below, size of F32, we want to do that. Okay, I think that's it. I'm not feeling good about this working. This feels like doing a bit too much. Undeclared identifier dynamic draw. Okay. GL static draw. Dynamic draw. And what is this? Dynamic draw. Where did you go? Dynamic draw. Use of undeclared identifier space black 559. Yeah, because there's no colors everywhere. So in the main space black, let's copy in these colors, and we did this after the shaders. Canvas height and width should be like two of the first things. Okay, there should be that. Use of undeclared identifier GL 589. Yeah, we can comment these things out. Okay. Buffer subdata. Offset plus size passes the end of the buffer. Okay, that explains why there's nothing on the screen, I guess. Buffer subdata. And we've got 32 of those warnings. Offset plus size passes the end of the buffer. but wasn't like buffer data that's meant to be the size? What if we just did a console log and printed out everything in this buffer, just to make sure we're getting like the correct kind of values. Let's also factor this out. This is going to print out so much information. What does it mean it doesn't have something called log? Okay. Okay, we need to like do this exactly once. Temp equals false or equals true. If temp equals false. Okay, yeah, so data got pushed, and this is kind of what I think what I'd expect. But why is there like negative numbers now? Okay, so already some of these values are a bit fishy in some way. Okay, so the texture coordinates are correct. The colors seem correct. These seem too big though. There must be something in here which is like, still assuming it's like 1,000 by 1,000. So we might just go back into the fragment shader and change it, the vertex color texture shader. Why is the finish with the background? We don't need that anymore. And make it just 1,000 again. Otherwise, like, the geometry might be cold if it's like outside of the display range. Okay. Oh, and then there's another error. So yeah, still not showing on the screen. But also, why is the this is 1 1 0 1 0 1 1 0. Yeah, like this stuff should all be correct and it looks fine. Why is this like negative so large? Okay, whatever like quote pause we chose here, we should reset that back to the main one. Just yeah, get that back. No, these numbers are way too large. these are not going to get normalized appropriately. Like, I don't think the issue is that the coordinates are too large, that the geometry is off screen and therefore it's not getting rendered, but it may be the case. I just make it really large and then we can normalize it at another stage. Okay, so now all of these large values are beneath 2,000, but yeah, we're not seeing them on the screen. Okay, some of them are negative though. Okay, but that's still okay. We'll sort this stuff out later. Okay, we have to fix this offset size passes the end of the buffer issue. So yeah, what is happening? So the other thing is that I don't think we've actually turned on the we haven't set up the VBO. That's why it's passing the end of the array, since the array currently can only draw 2 triangles. Oops. Okay, we actually needed this on. This better fix it. No. Okay, there's no errors, but where's the okay, the geometry is being drawn. Can you notice that there is a some of the dots in the background are missing? That's where it's getting drawn. Okay, it's just that at this point the animation 1 fraction is 0, but if we make the animation fraction 1 equal to 1, then and check this out. Oh, it's still okay, it's still not being displayed, but isn't that because we haven't changed the animation quote fraction? Wow, when we change the animation quote fraction to equal 1. Aha, there we go. Progress is being made slowly, but it's there. Okay. So now we're in a really good position to, like in some sense, we're like almost done. We now just like add in the game logic, and then a bajillion other rectangles are drawn, and then the grid's there. But before we get to that point, we need to center the rectangle again. So let's just save this. So much change. We've got texture drawing via vertex buffer and subdata, of course. Okay. So yeah, so now the next aim is to make move this over here to make that behave. So the original program assumed everything was 1,000 by 1,000. That is now changed. So where are the assumptions that everything is 1,000? So in the shaders, in the vertex color shader, we made this 2,000, but we really want this to be 500. And we want to normalize it, I guess invert it, and then use the inverted version here. This will require well, this is going to require some changes. When we make the we can actually get rid of this. Let's keep this temp stuff from now. So yeah, where's like the function that's drawing the rectangle here? Oh, that's right. So the actual width of the quote here is determining the rectangle, and it's really large. So if since the original game was 1,000 by 1,000 and now it's 100 by 100, if we reduce that like that, things should be fixed. And then if we change the center of the rectangle to 255 and 400 here, let's see if this gets the position back where it should be. Okay, now it's like super big, but generally in the right position. Refrain from a comment from what I just said. Why has this rectangle become so large when we kind of reduced the length of these things? This is unclear. Yeah, it's unclear. Why? What's going on? Is there something in the fragment? No. Surely there's nothing else in the shaders we need to adjust than just this. Right. Good thing we kept the debug star. We can just look at it. So currently it's taken up like 2/3, and well, it's going from like negative. Okay, so they're getting a 630 here and a 700. That enough, going outside the range. So yeah, why are we getting coordinates that large when we're multiplying the widths by half? So what these differences are like, we'll see. So in the new version, okay, so it is making them smaller. We're not, like, at least we don't get the entire screen, but something's still off. Yeah, the fragment shader is not. It's not the problem here. It's this one. Yeah, so we're just passing in coordinates that are just too large, and how like why? Oh, it's this is a really silly reason. This is really bad. It's just because the image we're passing in is like 1080 by 1080 because it's like the blue, not the actual quote QI. Okay. There wasn't really a bug at all. The bug was I was not using the proper image. There we go. The quote is there. the quote looks pixelated and crap, but we can fix that later. Okay, that is good. So then, yeah, let's save. Let's clean up some of the stuff in here. I guess we'll keep this here just in case we need it, but we're basically done. Okay. Okay, the quote GPU data doesn't need like the array to be this large. Like it's literally just drawing 6 vertices. So it's just, we can actually just really precisely say what it is. It's just this. Right? Yeah. So, I wonder if overflowing this would actually produce an error in Zig. In either case. Okay, in either case, we can make the quote fraction disappear for now. And look at that, look at that. Okay, now onto the stuff where we, let's also just reset the vertex buffer here to 0, where we start drawing all of the stuff. Okay, so we want to copy and compute grid geometry, which is a huge function with a lot of constants, a huge number of constants. And then we're just drawing to the color texture vertex heaps of times. Yeah, copy this in. And we will not be able to compile it, but we can see what's failing. Okay, so what does it want? So it needs center, grid, and grid width information. So we can copy in let's replace all of the current color, everything below shaders with these constants, which we're gonna have to update some of these. Okay, so colors, where here? What? Did I not just copy these in? So yeah, those have been superseded by all of these. So yeah, grid dimension, which I guess we also really need. Grid dimension is equal to, make it equal to 3. Ooh. It's now 500 by 500. I guess we want to change the tile width to 50 and the center to 250, 250. Okay, compile. Redeclaration of background shaded change time. 82 and 97. This kind of constant should be above. Use of undeclared identifier grid. Yep, we definitely need that. Oh, we really need to like start doing the init grid stuff. Init grid. Yeah, I guess we met. Let's just have a really basic, but like the random stuff shouldn't stuff things up, but I don't want to have to juggle with it right now. Let's just copy in a really basic version. To replace. Okay. So we init the clock, init the grid. Then what? We need. Okay, how do we define the grid again? The grid should be a global. Grid equals. Oh, it's like the main global of the game. Where is it defined? Why isn't it like? Here it is finally. So we had this after the textures. Okay. We can try again. Find tile index. That we do. We need to get find tile index. This vertex, this thing's annoying. Ah, and it compiled. Okay. Kind of moment of truth. Okay. Okay, so I think we have actually written the data. We're simply not yet calling for it to be rendered. So we can do that by, well, what's jumping to the render stuff? FN render. Come on. Yeah, so after the background is rendered, we then do yeah, render the tiles. So this is, I think we kind of know what we're doing. Like it's just, we're binding, we're saying, use the color texture shader, use blue marble texture, do buffer subdata, then draw array. So, yeah, so I can get rid of all of this. So here we're already reset all of that stuff. So then we want to say, no, we don't want to reset the buffer data index to be 0, absolutely not. We don't want to be doing that here. We want to do this like at the very end. Yeah, even having like a defer would be better. Yeah, we can just call this defer. Maybe we just set this in like the core geometry. We'll put it at the very end. And even if we don't set it earlier, it's done somewhere. Okay, so yeah, using color texture shader program, we then want to use the blue marble texture. We then want to convert the buffer data into the F32 like we did up here. We can clean this up once it's rendering. Let's just duplicate it for now. So this is the one where we'll probably need a lot. So now let's make this like 4,000. It's probably massively overkill, but actually maybe not. Like if it depends on the size of thing that's being drawn. If it's like a 6x6, it's like 36. Again, if it's like six vertices, you know, we'll make it big, whatever. So I guess we don't need to define that again. Tile GPU data object, and then we want to push it. So then we go we'll just call these. Compiled, and it's not drawing. Why? Yeah, why is this not drawing? Yeah, we know we can just switch between both textures when it's on the GPU, since we've done that many times. But weirdly, I'm not seeing this appear. We did, yeah, we did change this for the 480 version. Hey, what's happening? Could it be another size issue where these are going in too many different places? Let's do our debug, our size debug info. Oh, it's because the object here we're passing is empty. Another all of this is like copy pasta error. Okay. Beware the copy pasta error. Tile object, the tile data. Okay, let's try again. No, still not appearing. But we also commented this stuff out, so why is it appearing? Yeah, why is this appearing? Now I'm really confused. Okay, clear this. Let's just do like a remove everything from the Z cache. Remove everything from zig out. Build the sliding puzzle. Oh, okay. Weird that this wasn't picked up beforehand. So weird. It's 337. Yeah, what? Like, why? Why are we only now getting? Okay, this explains then why. Yeah, this explains why stuff wasn't working. Undeclared identifier animation direction. Okay, we've commented it out here. Grid movement direction. Where is this defined? Right here. We can insert this below the grid. Okay. Apparently that compiled, hopefully. Where's the oh, now the quote is nowhere to be seen. Okay, the quote is being drawn, it's just with the correct values, but again, where are these tiles? We can't, I don't see them. I don't see them being drawn. So now let's turn on the logging. Again, it's not there. Well, is something really bad happening with the cache? Like, yeah, why isn't this being drawn? Is it even compiling correctly? Yeah, where are my debug statements? Yeah, is the Z case just failing? Is it like actually, it's like not compiling correctly? Yeah, what's going on? So if we do a debug build, yeah, where is it? Like what? I have no idea what's going on here. How much did we change? We have changed a lot. But most of it's just been copying stuff in. Could it be like another overflow in some way? Stuff's getting drawn on the screen, so I don't think so. Dude, why isn't this stuff printing? Like, are we even getting execution down here? Okay, It is printing. It's just this stuff isn't happening. Oh, is it because we set temp to false somehow? It's like this part is just so annoying. Like none of this at all happens with desktop development because you're not dealing with some crappy layer of like abstraction between the code you're writing and what's actually on the screen. Why is this not printing? Can I just say like log vertex buffer f32 0 dot x? Can I even say that? F32 does not support field access. Okay, it is printed, and it's basically 0 that's printed. So data is getting printed. This seemed to be a really low value though. Yeah, why is this 3 to the power of negative e to the power of negative 13? That's basically 0. It shouldn't. Should it be there? Okay, well. Okay, so maybe this stuff is drawing. It's just it's being drawn in like weird locations. Okay, that might explain it. So yeah, what are the other cool? Okay, this would explain it since we copied in the constants, but we didn't. Oh, we did update them though. We changed like the tar width to be 50 and the center to be 250 to 50. That's the first one. So yeah, now I'm just totally confused why we can't why log is failing. This like loop statement we have here isn't even printing. This is kind of ridiculous. Yeah. Okay, let's just say okay, like Okay, let's say we even remove that statement, and we just print it repeatedly. Is even this going to work? Yeah. I need to compile it. No, it's just refusing to print. Wild. Totally wild. Well, okay, maybe we can do this in like a different way. Let's just print out the first two of these. If we can even do this. Okay, well, so it's just printing out the same like 0 value in each case. Okay, so it's if this truly is to be believed, then it means that nothing's getting written here. Oh, so if the vertex buffer index, if we've made this 0 too many times, then that would make sense since it's empty. Okay. Okay, yeah, I think it's like an empty array. Okay. Yeah, we've made it like 0 too many times. So we want to Oh, I think we're not even calling the function to construct it. Oh, this is such a noob error. My goodness. Okay. Yeah. We need to actually like do the compute grid geometry function. Yeah, we're not even calling it. Embarrassing. Okay. What else is there to do? Oh, there's so much here. Okay, but yeah, we want to do the compute grid. Okay, I kind of want to just like start wrapping this, like the animation loop needs to look as simple as this, and then there needs to be another function called render. So we'll go back to the sliding puzzle, and then in the animation loop, animation frame, we just want to call like yeah, compute grid geometry. The fact that it compiled like with that all those times and then like without the error really like, okay, oh wow, great, it's rendering. The tiles are not rendering though, and that's okay, and finally now the stuff is printing since it's not empty. Log, okay, go to this. So yeah, there's like a value somewhere that's set to like a 0 when it should be a 1, and like so. So yes, we've set this animation 1 fraction to be 1, but we want that to be a 0. This is 10. We can make this a 0 for now. Great, and we've got our tiles. Okay, some of the colors look a bit off. I guess this is because of like the tile width changes that we made. Okay, so let's just visually compare this to what we had. What it should be. Sliding puzzle. Seek out sliding. Sliding puzzle exe. So yeah, so a couple of things are off. So I think having the canvas be 500 by 500 is already a bit too small. We probably can. Well, if we want it to be this big on edge, then it kind of looks too small for me. We could just make it back to 1,000 again. Like, I think that could be okay. And then, yeah, let's try making those changes. So for the tile width, which is like 50, okay, before we do anything, let's just save it. So like, there's some like weird gray artifacts going on as well. Some like blurring thing going on. In this case. So what is changing? How's this vertex color texture changed? I guess we did add all of that. Got tile. Got tiles rendering. So yeah, let's change the size of this. This is like this is so tiny. Change it back to like 1,000. Make it 1,000 by 1,000. This means in the fragment shaders, have to change some of these again. That one's fine, but this one, change it back to 1,000. And then I think it was that. Change the center to 500, 500. Maybe it'd be good to like specify all of these in terms of like a single width somehow. That probably would be good. So okay, quit this. Build that again. Launch this again. Okay, and now, yeah, now the geometry has been pushed out of the way, so we can't see it. Maybe for now we'll just already getting to this point was we'll clean it up at the end. What git checkout, like we've done enough for today. Yeah, we have to zoom in, but it is getting ported. Yeah, so there's some like there must be some issue with the blur. Like it's, I don't know where this this weird gray where this gray stuff is coming from. I wonder if it's just how it's rendering here. Like the gap is not large enough for a single pixel, and so that's the result. I guess that itself could be adjusted. Say we decided to make the width of the tile from 50 to 100. Tile width. And then we compiled it. Okay, yeah, that was the issue. Okay, we might need to increase the gap then. This actually looks alright. What if we change it from like 100 to say like 75? And then make like the tile spacing 3. Yeah, that's getting better. Not quite there. Yes, the only problem now is that the quote is slightly cutting it off, but otherwise it's all right. And even then, we could probably move the quote down. No, I kind of want the size of this on the screen to be a bit bigger than this. Anyway, we'll play with this. We can play with this next time. But yeah, it's great. Now, like, yeah, now that this is on here, we are very close to the finish line. It's just a matter of figuring out how to do inputs with JavaScript, and then that will basically be done. Yeah. Thanks everyone for stopping by. And yeah, next time we will hopefully finish exporting this. But yeah, it already feels so good to have to have some like complex fragment shaders working. Yeah, and it'll be good. I think the game also should also load fast as well. Like if we say we clear the cache again, say we quit Firefox, launch a web server, and then load it. Damn, like that, it's just immediately loaded. At no stage when our game is, for any game we have on itch, is there going to be like, if it's web accessible, is there going to be like some like, you know, Unity Godot loading bar that like takes a minute? Like, that stuff's embarrassing. If you can do it by hand, you can do it. You can, yeah. If you want to do it well, you need to do it by hand. Okay. See everyone later. Bye.